please subscribe to support the channel. The universe is supposed to be majestic, predictable, and governed by elegant rules. Or at least that's what we tell ourselves to sleep at night. But when astronomers turned their most powerful instruments toward the void, the cosmos answered with horrors. Not monsters with teeth, but worlds forged so brutally that stepping onto them would be a mercy compared to what they truly do. Some planets don't just threaten life, they seem engineered to annihilate anything bold enough to stray near them. Worlds where storms slice, oceans boil, atmospheres crush, and gravity bends reality into shapes that should not exist. This planet doesn't attack with fire, freezing cold, or crushing pressure. It attacks with shards. It assaults with wind so fast it could strip the flesh off bone in seconds. And the glass? It rains sideways, carried by gales that outrun fighter jets. A storm that doesn't just hurt, it flays. This is the first world that forces you to reconsider what a storm even is. A world where the sky itself becomes a weapon. A world where stepping outside for even a fraction of a second would be the last mistake you'd ever make. Astronomers stared at its data in disbelief. How could a planet so deceptively Earth-like in color hide an atmosphere engineered to kill? What kind of violent physics powers winds faster than anything recorded in the solar system? How can a world this hostile remain intact at all? And why does it look, at a glance, so innocent? That mystery is what pulls us forward, deeper into this cosmic tour of horrors. Because the next destination isn't a frozen wasteland, a boiling desert, or a radiation blast zone. No, this is something much stranger, a world painted in stunning deep blue, yet capable of shredding every form of life with storms that travel at thousands of miles per hour. A razor storm planet that reminds us the universe has no obligation to be welcoming. So what kind of world disguises lethal chaos behind a peaceful blue glow? And why does it rain glass there? Astronomers first pointed their instruments at HD 189733b, expecting just another hot gas giant. Nothing unusual, nothing dramatic. The deep blue color made it look almost serene, like a giant sapphire floating through space. From afar, this planet could be mistaken for a peaceful cousin of Earth, a world with oceans or clouds reflecting starlight in breathtaking shades of cobalt. But the moment scientists analyzed its atmosphere, that illusion shattered. Because this planet isn't peaceful, it isn't calm, it isn't even survivable. It's a trap wrapped in beauty, a world hiding some of the most violent atmospheric forces ever recorded. What looks like a tranquil paradise is actually a nightmare wearing a disguise. The blue hue doesn't come from water or breathable sky. It comes from particles suspended in an atmosphere so chaotic that calling it weather feels like an insult to meteorology. The skies here don't behave. They don't cycle or shift like Earth's gentle winds. They scream, they tear, they rip through the planet with a ferocity that seems engineered to destroy anything foolish enough to enter the atmosphere. This planet doesn't merely have storms, it is a storm. The winds begin with speeds that already defy comprehension, but the deeper the data goes, the more disturbing the picture becomes. Here, the concept of a breeze simply doesn't exist. Instead, the atmosphere whips around the planet at 5,000 miles per hour, fast enough to circle the Earth in less than half an hour, fast enough to hurl debris with lethal force, fast enough to tear metal apart. Forget hurricanes, forget tornadoes. Those weather events are gentle whispers compared to the shrieking gales that dominate the skies of this world. This planet redefines what a storm is. It doesn't produce them, it is built out of them. But the speed isn't the most terrifying part, not even close, because within these roaring, unstoppable winds is something no human has ever experienced. No living creature could survive. Rainfall, if you can even call it that, falls not as water, not as ice, not as molten rock. It falls as glass, microscopic shards sharp as razors born from silicate vapor high in the atmosphere. The heat on the day side vaporizes minerals, and when that vapor cools as it whips around to the night side, it condenses into tiny blades. These shards don't drift softly downward, they are hurled sideways at hypersonic speeds, slicing across the planet in a deadly horizontal rainstorm. Picture an entire world where the sky turns into a perpetual sandblaster made of glass. Imagine winds so powerful that they don't just carry the shards, they accelerate them into weapons. No spacecraft could descend without being shredded long before reaching the cloud tops. No rover could land. No probe could survive long enough to send the final message. This planet is not merely uninhabitable, it is actively hostile. A place where the weather itself is aggressive, almost predatory. A beautiful killer drifting silently in space, wrapped in sapphire light and storms that pulverize anything that dares enter its atmosphere. And yet, as horrifying as that is, astronomers quickly realized this was only the beginning of the universe's extremes. Because while this planet shreds matter with storms, there exists another world where the primary danger isn't the wind or shards or pressure. It's heat so intense that it unravels atoms. A world not just hotter than any desert or volcanic field, but a planet hotter than some stars. A planet so blistering that molecules can't stay together. So violent that chemistry collapses the moment it begins. This world is the realm of glass storms and razor winds. Then the next one is a furnace beyond logic, a place where matter is torn apart simply for daring to exist on its surface. So what happens when you step on a planet where the temperature climbs high enough to vaporize metal instantly, and why does this cosmic inferno burn with the fury of a star? When astronomers first identified Kelt 9b, their initial measurements didn't make sense. A planet shouldn't behave like this. A world shouldn't reach temperatures that push the limits of chemistry itself. Yet this one orbits so close, so blisteringly near to its star, that its daylight side never sees even a moment of darkness. This world is forced to face its sun endlessly, bathed in radiation that would sterilize anything in seconds. But heat alone doesn't describe what's happening here. On Earth, high temperatures melt ice, boil water, soften rock. On Venus, they liquefy lead. But here, the heat reaches levels so oppressive that atoms lose their electrons. Gases behave more like plasma than air. Molecules shatter before they can bond. This isn't weather. This isn't climate. This is pure atomic chaos. Every square inch of the dayside is bombarded with relentless ultraviolet light far more intense than what Earth receives. At these temperatures, nothing solid could exist. Not rock, not metal, not mineral. Even the atmosphere itself begins to evaporate, peeling away into space under the onslaught of radiation. The heat is so overwhelming that the very concept of matter stability breaks down. Chemistry stops working. Reactions can't occur. The natural laws we rely on to explain the universe simply fail under this world's brutal conditions. And then comes the number that permanently seared this planet into astronomy's Hall of Horrors. 7,800 degrees Fahrenheit. Hotter than molten lava. Hotter than blast furnaces. Hotter than some small stars. At this temperature, iron doesn't just melt, it boils. Titanium and magnesium don't just soften, they vaporize. Any material we know, any substance we've ever created, would disintegrate into glowing vapor long before reaching the surface. This world is so hot that its atmosphere glows with the energy it absorbs, a scorching, roiling envelope of gas that blurs the line between planet and star. Scientists studying it describe a world in constant atomic disassembly, a world with no day-night cycle, only blistering eternity. A world whose winds try desperately to redistribute the heat, but fail, because nothing on this planet can resist the star's fury long enough to maintain structure. Even the night side, if it can be called that, remains hot enough to destroy most metals, evidence of how completely the star dominates the entire planetary body. But perhaps the most unsettling part is what this tells us. If the universe can create a planet hotter than a star, what other extremes are possible? What other rules can be bent, twisted, or shattered entirely? Kelt 9b proves that planets can burn, evaporate, and suffer atomic collapse, yet still remain whole enough to orbit their parent star. It proves that the universe has no problem ignoring what we think is possible. And if a world can be forged from flame, intense enough to obliterate metal, then what about a world forged from the opposite extreme? A place not bright, not blazing, but devouring light instead. Because while this planet is the universe's furnace, the next one is something far stranger. A planet so dark, it reflects almost nothing. A world that turns light itself into a prisoner. So what kind of planet lurks in space so black, so light-eating, that it can hide even while sitting in full view of its star? Astronomers first detected TRES-2b almost by accident. And even then, only because its orbit briefly blocked a sliver of starlight. At first, the data looked wrong. Planets reflect light, even dimly. They glow in infrared. They scatter photons. They reveal themselves. But this planet didn't. This planet refused. It was almost as if space itself had decided to take the shape of a world. A planet practically invisible to the universe, drifting through the cosmos like a black hole wearing a planetary mask. Not because it's far away, not because it's shrouded in dust, but because it is darker than any planet ever discovered. When telescopes focused on it, astronomers were stunned to see that it reflects only 1% of the light that hits it. That is less reflectivity than coal, than black paint, than freshly fallen ash. This planet is darker than the spines of interstellar dust clouds, darker than the shadows between galaxies. In the entire known universe, nothing classified as a planet absorbs this much light. It is so black that it barely exists to our instruments, appearing as a moving absence, a drifting void carved out of space. Watching it cross its star is like watching a piece of the universe glitch, as if reality is missing a chunk. This level of darkness is not normal. Gas giants generally reflect sunlight using clouds of ammonia or water vapor. Even worlds scorched by their stars still manage to scatter some light. But this planet drinks photons like a bottomless pit. And the more astronomers studied its atmosphere, the more disturbing the picture became. They found no comforting explanation, no thick oceans of soot, no swirling storms of carbon fibers. Instead, they discovered signatures of vaporized metals and chemicals so exotic, the scientists still aren't entirely sure what they're looking at. The atmosphere may be filled with titanium oxide, molten metallic vapors, or compounds so rare they barely exist on Earth except in specialized labs. Whatever the mixture is, it doesn't behave like any known atmospheric material. It doesn't scatter light, it doesn't reflect light, it consumes it. This planet may be hot enough to vaporize metals into the air, but instead of glowing brightly, it turns that energy inward, trapping heat, swallowing radiation, and radiating so little visible light back out that it might as well be a cosmic shadow. Even the faint glow it emits comes from its temperature, not reflection. An ember floating through space, seen only in infrared like a dying coal in a starless room. Looking at this world feels like staring into a void that somehow learned to orbit a star. A void pretending to be a planet. And the idea that something can exist in plain sight, yet be so thoroughly invisible, unsettles astronomers far more than any scorching furnace or glass storm nightmare. Because this world isn't just dark, it is unnaturally dark, hinting that the universe hides materials and chemistries we barely understand. But as eerie as this drifting shadow is, it isn't the most disturbing mystery waiting in the cosmos. Because while this planet devours light, the next one devours time itself. A world so dense, so gravitationally powerful, and so deeply linked with its star that it may actually be aging that star faster, warping time in the process. If TRES-2b is a void of darkness, then the next planet is a gravitational monster twisting the very fabric of space-time. So what happens when a planet becomes so massive and so close to its star that it begins pulling on time the way a black hole pulls on light? When astronomers first examined WASP-18b, they were struck by something deeply unsettling. This planet wasn't merely being shaped by its star, it was destroying it right back. The atmosphere, instead of circulating in calm bands or even violent storms, is constantly being stripped away, peeled off like layers of smoke caught in a cosmic vacuum. This planet isn't just losing its air, it's devouring it, dragging its own atmosphere downward under a gravity so intense that gases can barely stay aloft. Every moment, this world is suffocating itself, compressing its skies into oblivion as it clings desperately to whatever remains. What the deeper scientists looked, the stranger the situation became. The planet's gravity is so overwhelming, tens of times stronger than Jupiter's, that it doesn't merely affect the planet itself. It reaches outward, clawing at its star, tugging on it like an anchor tied too close. That gravitational pull is so extreme, it begins to interfere with the star's magnetic field, twisting it, warping it, destabilizing it. Normally, stars use magnetic cycles to regulate their activity, maintaining a kind of internal heartbeat. But orbiting so close, this planet disrupts that rhythm, choking the star's magnetic flow and forcing it into a premature slowdown. It's as if the planet is interfering with the star's natural aging process, like a cosmic parasite, altering the biology of its host. The magnetic chaos isn't just theoretical. The star itself shows signs of being older than it should be, not because billions of years have passed, but because the planet's immense pull artificially accelerates its aging indicators. This planet is spiraling inward, inch by inch, orbit by orbit, dragging itself closer to annihilation, while pulling the star's magnetic rhythm out of alignment. In the distant future, on cosmic timescales at least, this world will likely be torn apart by the star, shredded into a glowing ring of debris before finally disappearing. But until then, it distorts time around it, subtly altering the clockwork of stellar evolution in a way that should not be possible. Star and planet locked in a fatal dance, each dragging the other to a premature end. This is not a stable world. It's not a normal hot Jupiter. It's a gravitational aberration, a warning about what happens when mass, heat, and orbit combine into something the universe barely allows to exist. The closer researchers looked, the more disturbing it became. This planet is spiraling toward destruction. The star is aging faster than expected. Their relationship is a countdown. And the tension between them reveals something startling. Planets can influence stars in ways we never imagined, stretching not just matter, but time itself. But even a time-warping world isn't the strangest thing the cosmos hides. Because if WASP-18b is a gravitational menace collapsing inward, the next world is something far more dazzling and far more impossible. A world where storms don't bring rain, wind, or fire, but diamonds. A world where carbon is squeezed under pressure so immense it solidifies into gemstones, falling from the sky in shimmering torrents. So what kind of planet must exist for the universe to transform carbon into jewels and unleash storms made of solid diamond? Astronomers studying Neptune-like exoplanets quickly realized they weren't dealing with simple gas giants. These worlds hide something extraordinary beneath their hazy, blue-tinted atmospheres, layers where carbon doesn't behave like it does on Earth. Instead of forming graphite or drifting as gas, carbon undergoes transformation so intense, so alien, that the line between planet and gemstone begins to blur. These are planets where the universe's most common element becomes its most precious. A world where carbon is pressed, squeezed, and tortured into new shapes until it crystallizes into jewels. The mystery begins deep beneath their frigid clouds. Temperatures rise sharply as pressure climbs, turning simple molecules into complex structures. Go deeper, and the atmosphere thickens into exotic fluids. Deeper still, the pressure begins to exceed anything found on our planet. Not even Earth's core compares. The crushing force can reach millions of atmospheres, squeezing carbon atoms into arrangements they would never adopt naturally on any surface we've ever walked on. Under this unimaginable weight, carbon undergoes a metamorphosis. Graphite compresses, bonds tighten, and simple crystal lattices snap into rigid perfection. What emerges isn't rock or coal or soot, it's diamonds. Scientists believe that methane in the atmosphere is broken apart by lightning or heat, freeing carbon atoms that fall into the depths like microscopic snow. As they descend, the pressure mounts until those atoms fuse into diamond crystals, creating hailstones of pure, solid carbon. These crystal fragments continue to fall, growing as they pass through denser and hotter layers, eventually forming chunks large enough to be considered geological structures. In many models, these diamonds don't stop falling. They sink all the way down to form a diamond ocean, a sea of liquefied carbon beneath a crust of solid gemstone. Picture thunderstorms raging above an ocean of molten carbon. Picture lightning splitting methane molecules, birthing carbon flakes that fall downward as brilliant shards, eventually dissolving into a glowing, churning sea of liquefied diamond. These worlds redefine what a storm can be and what oceans can look like. They are reminders that the universe doesn't care about the materials we prize. It manufactures them in bulk, shaping them into alien landscapes far beyond human imagination. But those sparkling infernos are only one flavor of cosmic extremity. Because if WASP Team B is a gravitational menace collapsing inward, the next world is something far more dazzling and far more impossible. A world where storms don't bring rain, wind, or fire, but diamonds. A world where carbon is squeezed under pressure so immense it solidifies into gemstones, falling from the sky in shimmering torrents. So what kind of planet must exist for the universe to transform carbon into jewels and unleash storms made of solid diamond? Astronomers studying Neptune-like exoplanets quickly realized they weren't dealing with simple gas giants. These worlds hide something extraordinary beneath their hazy, blue-tinted atmospheres, layers where carbon doesn't behave like it does on Earth. Instead of forming graphite or drifting as gas, carbon undergoes transformation so intense, so alien, that the line between planet and gemstone begins to blur. These are planets where the universe's most common element becomes its most precious, worlds where carbon is pressed, squeezed, and tortured into new shapes until it crystallizes into jewels. The mystery begins deep beneath their frigid clouds. Temperatures rise sharply as pressure climbs, turning simple molecules into complex structures. Go deeper, and the atmosphere thickens into exotic fluids. Deeper still, the pressure begins to exceed anything found on our planet. Not even Earth's core compares. The crushing force can reach millions of atmospheres, squeezing carbon atoms into arrangements they would never adopt naturally on any surface we've ever walked on. Under this unimaginable weight, carbon undergoes a metamorphosis. Graphite compresses, bonds tighten, and simple crystal lattices snap into rigid perfection. What emerges isn't rock or coal or soot, it's diamonds. Scientists believe that methane in the atmosphere is broken apart by lightning or heat, freeing carbon atoms that fall into the depths like microscopic snow. As they descend, the pressure mounts until those atoms fuse into diamond crystals, creating hailstones of pure, solid carbon. These crystal fragments continue to fall, growing as they pass through denser and hotter layers, eventually forming chunks large enough to be considered geological structures. In many models, these diamonds don't stop falling. They sink all the way down to form a diamond ocean, a sea of liquefied carbon beneath a crust of solid gemstone. Picture thunderstorms raging above an ocean of molten carbon. Picture lightning splitting methane molecules, birthing carbon flakes that fall downward as brilliant shards, eventually dissolving into a glowing, churning sea of liquefied diamond. These worlds redefine what a storm can be and what oceans can look like. They are reminders that the universe doesn't care about the materials we prize. It manufactures them in bulk, shaping them into alien landscapes far beyond human imagination. But those sparkling infernos are only one flavor of cosmic extremity. Because if WASP Team B is a gravitational menace collapsing inward, the next world is something far more dazzling and far more impossible. A world tidally locked so fiercely that its exposed side is a bottomless cauldron of molten rock. Not diamond oceans, but lava oceans. Not jewel storms, but volcanic tides that glow like fresh forged metal. A world so blisteringly hot that it may have never known a single solid moment in its entire existence. So what happens on a planet where the daylit hemisphere is forever melted, dripping and boiling like the surface of a star? Astronomers had seen hot worlds before, but nothing prepared them for the discovery of 55 Cancri E, a planet whose daylight side is locked in an eternal state of meltdown. This isn't a place where the ground heats, cools, and reheats in a cycle. This is a hemisphere permanently exposed to its star, scorched without mercy, forged into a glowing landscape that never cools, never solidifies, never rests. A world where morning never arrives because it's already too late. Every moment on the day side is a violent, blistering noon. The mystery began when telescopes detected heat levels far beyond anything expected for a world of its size. It wasn't just hot, it was molten. The reason is tidal locking. This planet always keeps the same face turned toward its star, like the moon does with Earth, but under far, far harsher conditions. The star's gravitational grip forces one hemisphere to roast endlessly, while the opposite hemisphere remains trapped in endless darkness. There is no twilight, no gradual heat change, only a stark division between night and a perpetual inferno. And when astronomers calculated the temperature of the exposed side, the numbers made even better and researchers pause. 4,700 degrees Fahrenheit. Hot enough to reduce steel to liquid. Hot enough to melt iron as if it were candle wax. Hot enough that the very notion of solid rock becomes meaningless on half the planet's surface. What forms instead is a vast, shimmering ocean, not of water, but of lava. Rivers of molten rock surge across the dayside, reshaping the terrain constantly. Volcanoes erupt not sporadically, but continuously, their eruptions feeding into the glowing seas that stretch for hundreds of miles. The crust is so thin and unstable that it crackles like the surface of a furnace, shifting under the immense heat. This planet doesn't have continents, it has rafts of semi-solid rock drifting atop a world-scale cauldron. Scientists think the atmosphere itself could be laced with vaporized minerals, creating chemical clouds that condense into molten droplets before splashing into the lava below. Even the night side, though cooler, is no refuge. Some models suggest the lava may circulate, dragged by atmospheric winds or internal flows, causing pockets of heat to spill over into the darkness. This world is a living kiln, an entire planet remade into a single sprawling volcanic ocean. Standing on the dayside would be impossible. The ground itself would behave like a boiling liquid, collapsing underfoot or erupting beneath you. Every horizon would glow red. Every breath would be superheated gas. Every heartbeat would be your last. Yet as extreme as this molten hellscape is, the universe is not done escalating. Because while this planet melts, another world suffers a very different fate. Its surface is blasted so violently by its star that its atmosphere explodes away every single day. Not once, not seasonally, every day. A world that looks Earth-like from afar, but experiences death-level radiation on a scale that strips its sky off again and again. So what kind of world loses its entire atmosphere daily under the assault of ferocious stellar flares powerful enough to tear planets apart? From a distance, Kepler 438b could fool almost anyone. Its size resembles Earth. Its orbit lies in the star's so-called habitable zone. Its overall temperature profile, at first glance, seems almost reassuring. When astronomers first saw the data, there was a moment, a brief, delicate moment, where they wondered if this could be one of the rare worlds with the right ingredients for life, a possible sibling to Earth, a distant cousin of our blue home. But that illusion shattered the instant they studied the star it orbits. Because this world doesn't circle a calm, gentle sun, it orbits a monster. A star whose violent temper turns the planet into a battlefield. A world that looks like Earth from afar, but up close, is as deadly as a planet can be without melting. Its parent star unleashes flares so intense that they make the sun's worst tantrums look like sparks from a matchstick. These eruptions aren't the polite bursts of plasma we observe with solar telescopes. These are superflares. Detonations of magnetic fury that release hundreds of times more energy than any flare our sun has ever produced. When one of these superflares erupts, it hurls a tidal wave of radiation and charged particles straight into space, carving through planetary atmospheres like a blowtorch through plastic. And Kepler 438b sits directly in the line of fire. The tension rising around this world comes from the frequency of those blasts. On Earth, major flares are rare, years apart. On this world star, superflares erupt with terrifying regularity. Some estimates suggest major blasts occur every few hundred days. If you stood on the surface, which you couldn't, not for a second, you would see the sky light up with searing radiation storms over and over again, each powerful enough to sterilize life, electrify the atmosphere, and ignite chemical reactions that tear apart everything they touch. And because the planet is so close, it absorbs the full force of these events. When the radiation hits, the atmosphere doesn't just shake, it detaches. Superflares slam into the upper layers with explosive force, stripping them away, sending gas streaming into space at thousands of miles per hour. The planet desperately tries to rebuild the atmosphere between events, outgassing from the crust or pulling volatiles from its surface. But the next flare rips it apart again, over and over, an endless cycle of destruction and recovery, like a world suffocating repeatedly, never able to draw a full breath before its sky is peeled away once more. What remains is a planet that looks Earth-like only from the safest possible distance. Up close, it is a world under constant assault, a place where the surface is bathed in radiation intense enough to sterilize entire continents. No oceans, no forest, no breathable air, only a scorched shell gripping whatever fragments of atmosphere survive between stellar attacks. If Earth had to endure even a fraction of the star's rage, our atmosphere would be shredded in hours, our oceans boiled off in days, and our planet left barren within a single human lifetime. And yet, as terrifying as this is, the next world takes the brutality of alien weather to levels that defy imagination. Because the next planet doesn't lose its atmosphere. The next planet weaponizes it. The clouds are not made of water vapor. The storms don't bring harmless rain. This next world brews clouds of metal heated until they vaporize. And when night falls and temperatures drop, that metal condenses and rains downward as molten iron. So what kind of planet turns its skies into smelting furnaces and produces storms that shower molten metal from above? Astronomers expected WASP 76b to be extreme. Any world orbiting that close to its star would be. But they didn't expect this. When they first examined its atmospheric spectrum, they saw fingerprints of metals where no metals should be. Not deep underground, not locked inside rock, floating in the clouds. This planet carries metallic vapors in its sky the way Earth carries water. A world where the clouds themselves are infused with iron, drifting in the upper atmosphere like shimmering metallic fog. A planet whose skies behave like the inside of a steel mill. The mystery deepened when researchers realized what those chemical signatures implied. The temperatures on the day side are so overwhelmingly high that solid iron evaporates, not melts, evaporates. It becomes vapor, rising into the air to form clouds of metal that swirl across its atmosphere. On Earth, iron is the backbone of our civilization, hard enough to build skyscrapers, resilient enough to forge machines, strong enough to structure entire cities. On this planet, iron is nothing more than steam. Its day side reaches temperatures beyond 4,300 degrees Fahrenheit, enough to strip electrons, weaken atomic bonds, and turn a metal we use for bridges into a ghost drifting across the sky. The tension grows when you realize how unbalanced this world is. It's tidally locked, meaning one side is punished by eternal daylight while the other remains frozen in perpetual night. Though frozen is relative here. The difference between light and darkness becomes a brutal thermal tug-of-war. Winds rage across the Terminator zone, dragging superheated metal vapor from the blistering day side into the cooler night side. As that molten hot atmosphere crosses into darkness, the temperature plummets by thousands of degrees in minutes. And something terrifying happens. The vaporized iron condenses. The moment the metallic clouds cross the line where daylight ends, the iron turns back into liquid, molten droplets suspended in a turbulent storm. Those droplets grow, collide, merge, and finally fall. Except this rainfall isn't water. It's not even lava. It's molten metal, pouring from the sky like showers of glowing silver. Imagine standing there, though you'd be dead in seconds, and hearing the metallic hiss of an atmosphere turning into a smelting rainstorm. The sound of liquid iron splattering across scorched surfaces, forming rivers of metal that steam, boil, and evaporate again when the winds drag them back toward the day side. A continuous cycle of vaporization, transport, condensation, and fiery descent. This planet's weather is a factory of molten metal storms. Its atmosphere is a furnace that never cools. And the idea that entire worlds exist where iron rain is normal stretches the limits of what we think planets can be. On Earth, steel forging requires furnaces, machinery, oxygen-controlled chambers. Here, the sky itself does the forging. Yet as violently surreal as this world is, the universe has an even more chaotic horror waiting. Because while this planet rains molten iron at the boundary between day and night, the next planet unleashes winds that go beyond destruction. Winds that don't just move fast, but move at speeds so intense that they surpass the fastest bullets ever fired. Storms that appear and ignite in seconds. A world where temperature swings are so catastrophic that the atmosphere practically detonates with every orbit. So what kind of planet produces winds topping 11,000 miles per hour, fast enough to shred anything that dares enter its sky? Astronomers were baffled when they first studied HD 8606b because nothing about this planet behaves in a stable, predictable way. Instead of a smooth orbit, it whips around its star on one of the most elongated paths ever recorded, an orbit so stretched that the planet spends most of its time freezing in deep space, only to dive inward and scorch in a sudden catastrophic burst of heat. This violent swing from frigid cold to star-blasting temperatures creates one of the most extreme atmospheric transformations in the known universe. The mystery wasn't just that it gets hot, it was how fast it happens. This is a world where the temperature can skyrocket by 1,000 degrees Fahrenheit in a matter of hours, a planet whose atmosphere doesn't warm gently, but ignites. As the planet slingshots toward its star, the atmosphere absorbs a colossal wave of radiation. The heating is so abrupt and so intense that the air itself behaves like explosive fuel. Storms don't slowly build, they erupt instantly. Temperature shockwaves travel around the globe faster than the atmosphere can respond, triggering chain reactions that tear through the skies with violent precision. The gases expand, ignite, and compress in patterns that resemble atmospheric detonations more than weather. Clouds form and evaporate almost simultaneously. Pressure waves collide like atmospheric shock fronts. The entire sky becomes a cauldron of chemical reactions that would annihilate anything attempting to descend. But the real terror comes from the wind. When the planet hurtles close to its star, the day side superheats so violently that the air rushes toward the cooler night side like a colossal tidal wave. The atmosphere doesn't simply circulate, it accelerates. It rips. It screams across the globe at speeds no machine could withstand. Researchers calculated that the winds reach over 11,000 miles per hour, faster than a rifle bullet, faster than hypersonic jets, faster than any wind in the solar system by a margin so large it feels almost fictional. At these speeds, particles in the air become weapons, dust becomes shrapnel, molecules strike with lethal force. A spacecraft entering this atmosphere would be torn apart in milliseconds, its hull shredded into vapor by a hurricane made of razor-edged wind. Even the atmosphere itself is not stable. The heat surge causes enormous currents that rise and fall in towering walls, collapsing under their own momentum. Pressure systems slam into each other like titanic collisions. Storm cells don't drift, they detonate and reform in the blink of an eye. If wind on Earth is a gentle push, wind on this planet is a planetary-scale execution. Entry is impossible. Descent is suicide. Survival is mathematically non-existent. Yet the universe doesn't stop at nightmare winds. There is a stranger world, twisted, distorted, and warped by the very star it orbits. While this planet is ripped apart by speed and heat, the next one is reshaped by crushing gravitational forces, pulled so violently that it doesn't remain round. Its entire body stretches, distorts, and elongates until it resembles a cosmic football. And with that distortion comes the slow, deadly process of being eaten alive by its star. So what happens to a world when gravity doesn't just influence it, but reshapes it into something no longer recognizable as a sphere? Astronomers knew WASP-12b would be intense the moment they saw its orbit, but nothing prepared them for the grotesque shape their measurements revealed. This world is not round. It is not the comforting sphere that gravity naturally forms. Instead, it has been stretched, pulled like cosmic taffy by the overwhelming tidal forces of its star. Gravity has sculpted the planet into an elongated football-like shape, a body deformed by forces so strong they override the planet's own ability to hold itself together. This is not a stable world. This is a world being torn apart, slowly, relentlessly, inevitably. The mystery deepened when researchers studied the spectral data of its atmosphere. Instead of a sealed, self-contained envelope of gas, they saw streams, long trailing streams of material flowing away from the planet. Its star wasn't just influencing the atmosphere, it was stealing it. The heat and gravity are so extreme that the atmosphere bulges outward, stretching toward the star like a luminous bridge of gas. Once the gases cross a certain point, they can't return. The star plucks them away, atom by atom, pulling the atmosphere into itself like a hungry flame consuming dry paper. And the tension rises further when you understand how quickly this is happening. The planet is losing mass at a staggering rate, thousands of tons of gas ripped away every second. It is literally being eaten alive by its own sun. The gases that once formed its outer layers now swirl around the star as a glowing halo, a ring-like cocoon of stolen material. The star feasts on the planet while the planet spirals ever closer, locked in a deadly embrace. WASP-12b is not orbiting so much as sinking, falling inward as tidal forces tear it apart piece by piece. Eventually, the planet will be gone entirely, consumed until nothing remains except a faint chemical trace in the star's outer layers. Imagine the final days of this world, a shrunken core wrapped in a thinning shell of gas, dragged inward as the star rips away the last shreds of atmosphere. It is a cosmic slow-motion execution. No other fate awaits it. No rescue, no stabilization, only dissolution. Yet as horrifying as this slow planetary consumption is, the next world takes a different form of torment, one not defined by heat or gravity, but by darkness. A place where one half of the planet is locked in eternal night, a side so cold and so isolated that it never sees even a sliver of daylight. A world where rock vaporizes under constant sunlight on one side, while the other remains a frozen, silent wasteland. A planet of extremes so severe that storms of rock itself sweep across the boundary between light and shadow. So what kind of world lives in perpetual darkness, with one half scorched into glowing stone, while the other lies in trapped, icy, silent night? Astronomers describe Kepler-10b as a world divided against itself, a planet split cleanly into two realms that might as well belong to different universes. One half is locked in eternal daylight, scorched by its star without pause or mercy. The other half lives in endless night, a frozen desert that never sees even a sliver of daylight. This is not a planet with days and seasons. This is a planet with sides, each locked into a permanent, unforgiving fate. The mystery isn't just the contrast, it's how such extremes coexist on a world only a little larger than Earth. The moment researchers calculated the surface temperature of the day side, they realized this planet wasn't merely hot, it was beyond geological comprehension. The sunlit hemisphere climbs to temperatures exceeding 2,500 degrees Fahrenheit, hot enough to melt granite, vaporize minerals, and liquefy the crust into glowing, molten plains. There is no solid ground in many regions, only bubbling lakes of rock and oceans of partially melted minerals that churn like metallic lava seas. The surface behaves less like a planet and more like the exposed mantle of a broken world. On the night side, however, the temperature drops by thousands of degrees. Without sunlight and without an atmosphere thick enough to distribute heat, the dark hemisphere freezes into a brittle wasteland. Any vapor drifting across the boundary condenses instantly into frozen dust, coating the terrain in mineral frost. The contrast is so severe that the planet becomes a cosmic paradox, molten fury on one side, glacial silence on the other. No twilight, no dawn, just a razor-sharp line dividing the blazing and the frozen. But the most unnerving phenomenon occurs along that Terminator line, where day meets night. The unbelievable heat from the day side vaporizes rock, actual rock, into mineral gases. These vapors rise into the superheated air, then drift toward the cooler dark side. As they cross into the shadows, the gases condense, forming storms of rock vapor that precipitate out as mineral grains. This planet doesn't have rain or snow in any familiar sense. It has stone weather, clouds of vaporized silicates condensing into showers of rock that accumulate like ash across the twilight region. The atmosphere, thin as it is, becomes a conveyor belt for geological cycling, turning stone to vapor, vapor to stone, over and over again. If a human were somehow able to stand precisely between day and night, where molten rock meets frozen crust, they'd see a skyline of shimmering vapor clouds, each carrying the essence of mountains, cliffs, and boulders dissolved into the air. They'd hear the hiss of minerals raining down, the crackle of superheated winds, the groan of expanding and contracting crust. Every footstep would rest on ground that spent its existence oscillating between melting and freezing. The planet's heartbeat is the tension between these two extremes. Yet even this world, with its rock vapor storms and razor-thin divide between fire and ice, isn't the strangest destination in the galaxy. Because somewhere out there exists a planet that takes the idea of pressure to a terrifying extreme. A world so dominated by water that it barely has any land at all. Not oceans above solid ground, but water above more water, layered beneath crushing forces that create exotic forms of ice and fluids unknown on Earth. A world where the familiar substance we drink and swim in becomes something alien, compressed into materials that behave like neither liquid nor solid. So what kind of planet is so flooded, so pressurized, that water itself transforms into impossible states deep below its endless clouds? Astronomers quickly realized GJ1214b was not like anything in our solar system. It wasn't rocky like Earth, nor was it a gas giant like Neptune. It occupied a strange middle ground, a world so dominated by water that the very concept of a surface becomes meaningless. When researchers ran their models, they found something astonishing. This planet appears to have no solid ground at all, just layer upon layer of water in conditions so extreme that familiar physics starts to warp. This is not a blue planet like Earth. This is a water world so deep, so pressurized, that the oceans themselves behave like substances we've never seen under natural conditions. The mystery begins with that overwhelming abundance of water. The planet is several times more massive than Earth, which means gravity presses down with brutal intensity. Near the top layers, the water may feel somewhat familiar, steam, cloud, oceanic vapor, but as you descend, pressure skyrockets to levels far beyond anything possible on Earth's seafloor. And the deeper you go, the more water stops acting like water. The molecules are squeezed so tightly that they begin rearranging into exotic forms. This isn't warm ocean water. This isn't even superheated steam. This is water forced into new identities, bent by pressure into states that barely resemble the substance flowing in Earth's rivers. Go deeper still, and the tension becomes almost unbearable. Temperatures rise, pressure mounts. The water stops being liquid or gas and becomes supercritical fluid, a bizarre state where the distinction between liquid and vapor disappears entirely. It has the density of a liquid, the freedom of a gas, and the heat of a furnace. It can dissolve materials that would normally sink. It sloshes and swirls in ways that look almost alive, spreading heat across the planet with terrifying efficiency. On Earth, this supercritical state can only be created inside high-pressure industrial chambers. On this planet, it is the default condition beneath the clouds. But the most strange layer lies even deeper. Under imaginable pressure, hundreds of thousands of atmospheres, the water molecules are forced into rigid crystalline formations that cannot exist on any natural place on Earth. These minerals are called exotic ices, solid phases like Ice 7 and Ice X. They don't melt at high temperatures. They form under crushing pressures that compress hydrogen bonds into lattices unthinkable on our planet. Imagine an ocean floor not made of rock, but of ice that's hotter than any boiling pot on Earth. Ice that forms because pressure commands it to. A planet where the ground is burning hot crystal, buried beneath miles upon miles of supercritical water. This world challenges everything we think we know. A planet where water can behave like molten quartz, like glowing vapor, like liquid metal, depending on the depth. A planet where diving deeper isn't to swim, it's a transformation into zones of increasingly alien physics. A world without continents, without mountains, without any solid place to stand. Just endless, crushing layers of water in every form the universe can force it into. Yet even this liquid colossus isn't the strangest gravitational marvel waiting in the cosmos. Because somewhere else, drifting through the galaxy, is a world trapped in a cosmic tug-of-war so chaotic it orbits 3 suns. Its days twist unpredictably, its shadows warp and multiply. Sometimes all 3 suns rise at once, sometimes none do. A world locked in a perpetual gravitational struggle, its path rewritten moment by moment by the competing pull of 3 stellar bodies. So what kind of planet survives in a system where 3 different suns constantly battle for control of its orbit? Astronomers were stunned when they realized KOI 5AB wasn't orbiting 1 star, or even 2. It was trapped in the gravitational crossfire of 3 suns. Most planets live quiet, predictable lives, circling a single star in a stable path sculpted by simple orbital mechanics. But this world has never known stability. Instead, it's locked inside a cosmic tug-of-war, yanked in competing directions by 3 massive stellar bodies whose gravitational fields collide, overlap, and distort each other like writhing whirlpools of force. From the moment scientists mapped the system, one question echoed through the research teams: how does a planet survive here at all? The tension rises the deeper you look into that orbital chaos. Each of the 3 suns pulls with a slightly different rhythm, one tugging steadily, another oscillating in a wide orbit, the third looping in unpredictable arcs. The result is a gravitational battlefield where no 2 days are ever the same. Instead of experiencing a regular sunrise and sunset, this planet may endure days where multiple suns rise at once, flooding the sky with overlapping beams of light. Other days, one sun may slip behind another, plunging the world into partial shadow. There might even be bizarre intervals where no sun is visible because of the complex orbital geometry, leaving the planet unexpectedly dark in a system full of stars. Every shift in the positions of the 3 suns tugs the planet's orbit into new angles and trajectories. Its path is so warped, so continuously rewritten, that astronomers liken it to a cosmic dance choreographed by forces that do not care for symmetry or rhythm. Seasons don't exist. Weather patterns can't stabilize. Climate never settles long enough for even the simplest form of habitability. The world is at the mercy of gravitational currents that twist its orbit millimeter by millimeter, year after year. What should be a simple ellipse becomes a distorted, constantly shifting track that changes subtly with every revolution of the 3 blazing giants around it. Imagine standing on the surface, if such a place were solid, looking up to see suns drifting in and out of view like wandering lanterns. Sometimes the sky would blaze with triple daylight, shadows overlapping and merging. Other times you'd see 2 suns battling for dominance, while the third lurks behind them, waiting for its turn to rise. And then, unexpectedly, long stretches of dimness might descend as orbital alignments momentarily deny the planet any direct sunlight at all. Time loses its meaning here. Day, night, and season melt into a chaotic sequence dictated by gravity's unpredictable choreography. This planet is a survivor of imbalance, a world that should have been flung out of its system long ago or swallowed by one of the stars. And yet somehow it clings to existence, circling and weaving through gravitational currents that would tear lesser worlds apart. KOI 5AB shows us that the universe isn't bound by what we consider stable. It can sculpt solar systems that operate like cosmic puzzles, locked in complex patterns far beyond our everyday experience. But chaotic as this triple star world is, the universe has something even stranger waiting. Because out there is a planet that didn't stay put. A world that astronomers saw clearly, documented carefully, and then watched as it vanished. Not drifted behind a star, not dimmed or flickered. It disappeared. Years later, a faint signal suggested it might have reappeared, leaving scientists baffled about what it truly was. So what kind of planet shows itself to humanity, only to dissolve into nothingness, leaving behind a mystery so deep that even now no one agrees whether it ever truly existed? When astronomers first spotted Fomalhaut B, they celebrated. It was one of the rare exoplanets actually seen with direct imaging. Not inferred, not detected through a wobble or dimming, seen. A bright point of light orbiting a nearby star, glowing in the darkness like a small cold lantern. But then something uncanny happened. Years later, when telescopes turned back to the same location, that point of light was gone. Not dimmer, not obscured, simply vanished. It was as if the planet had evaporated, dissolving into the void without leaving as much as a trace. At first, researchers assumed the mistake. Instruments fail, data misleads, optical illusions happen. But observation after observation came back empty. The world that once appeared so clearly had slipped out of existence. The tension built as astronomers tried again and again to relocate the object, scanning the star's debris disk, combing through imaging records, searching for even the faintest signature of the planet's return. Nothing. Every attempt to find it ended in failure. The mystery wasn't just its disappearance. It was the sheer impossibility of losing an entire planet. Then came the unsettling revelation. Perhaps it had never been a planet at all. The spectral data, once reanalyzed with more sensitive instruments, hinted at something stranger. The object's brightness didn't match what a stable planet should produce. Instead, it was too diffuse, too inconsistent, too easily disrupted. Some astronomers began to suspect that the planet might have been a cloud of debris, possibly the aftermath of a catastrophic collision between two icy bodies. A dispersed, shimmering cloud reflecting starlight just long enough to masquerade as a world before spreading outward and fading from view. If that's true, Fomalhaut B wasn't a planet that disappeared, it was a planet that never was. The ghost of a collision captured in a rare moment before dissipating. And that possibility is even more haunting, because it means the universe may be littered with ghost worlds, short-lived structures that look like planets for only a sliver of time before dissolving back into dust. Worlds that flicker in and out of existence, caught only briefly by the narrow gaze of our telescopes. Fomalhaut B reminds us that not everything we see is permanent. Some celestial planets are illusions, sculpted by destruction. But while this ghost world faded into nothingness, the universe holds plenty of planets that are all too real and far more hostile. Because the next world isn't a vanishing phantom, it's a frozen monolith cast into near total darkness. A planet so cold, so distant, so starved of starlight that its surface temperature plunges to levels where even nitrogen freezes solid. A world made almost entirely of ice, locked in darkness so absolute that it barely receives the warmth of its own star. So what kind of planet lies in eternal night, frozen solid from crust to core under temperatures colder than deep space itself? Astronomers nicknamed Ogle 2016 BLG 1195LB the Hoth planet the moment its characteristics became clear. An Earth-sized world drifting in conditions so cold it borders on the impossible. The mystery begins with its isolation. This planet orbits so far from its dim, nearly invisible star that for all practical purposes, it exists in starless darkness. Its parent star is barely more luminous than a failed ember, giving off so little light that the planet receives less warmth than Pluto does from our sun. From a distance, it appears as a small, silent sphere, lost in an ocean of black, locked away from cosmic warmth as if the universe itself abandoned it. The tension grows when you realize just how little radiation reaches this world. Its star is a faint, ultra-cool dwarf, so faint it's difficult to detect even with modern instruments. The planet orbits at a distance where the starlight is so weak, so diffuse, that standing on the surface would feel indistinguishable from standing in open interstellar space. The sky wouldn't brighten, shadows wouldn't form, the sun would appear as a tiny, ghostly pinprick, far dimmer than a full moon and unable to warm even the upper layers of the atmosphere. If Kepler 438b was defined by overwhelming radiation, this world is defined by the near total absence of it. And then comes the revelation. Its surface temperature plunges to levels far below anything Earth has ever encountered. Colder than the poles of Pluto, colder than the vacuum-chilled shadowed craters on the Moon, colder even than the cosmic average of interstellar space. Estimates place its surface around -400 degrees Fahrenheit, a temperature where nitrogen, oxygen, carbon dioxide, and most familiar gases would freeze into solid crystals. The surface would be a wasteland of frozen molecular ices layered atop each other, nitrogen glaciers, carbon monoxide frost fields, and perhaps oceans of methane frozen into glassy slabs thicker than mountains. Even the planet's core heat cannot meaningfully warm its surface. The cold penetrates so deeply that the entire world is locked in a cryogenic stasis. This is a planet where time feels slowed by temperature alone. No storms, no oceans, no atmosphere in the sense we know it, just a thin whisper of frozen gases hugging a surface colder than scientific instruments are designed to withstand. A silent world suspended in eternal twilight, orbiting a star barely brighter than a candle flame in the vacuum. If life ever attempted to spark here, the cold would smother it instantly. But as paralyzing and still as this frozen world is, the next planetary nightmare couldn't be more different. Because somewhere else in the galaxy lies a planet dominated not by ice, not by darkness, but by speed. A world so dense and so gravitationally stressed by its dead star companion that it spins with a ferocity that breaks expectations. A world whose very existence challenges the limits of orbital mechanics and rotational stability. A planet that should tear itself apart, yet somehow doesn't. So what kind of planet orbits so fast, so tightly, that it rotates with impossible speed, hinting that it may not be a world at all, but something far stranger? Astronomers were already intrigued when they detected a planet orbiting PSR J1719-1438, because this wasn't a world circling a normal star, it was orbiting a pulsar, an ultra-dense corpse of a supernova. A dead star compressed into a sphere barely larger than a city, yet heavier than our entire sun. Right away the mystery sharpened. How could any planet survive in an environment so extreme, so violent, so drenched in radiation that even atoms struggled to remain intact? Yet there it was, circling the stellar remains like a ghost tied to a cosmic tombstone. To understand the terror of this environment, you have to imagine the nature of a neutron star. Its gravity is so strong that a teaspoon of its material weighs billions of tons. Its magnetic fields whip through space with unimaginable strength, and it spins fast. This pulsar rotates hundreds of times per second, firing beams of deadly radiation into space like a cosmic lighthouse. Any nearby object is subjected to those beams, bombarded with blasts powerful enough to sterilize worlds instantly. The space around it is a war zone of relativistic particles, magnetic chaos, and lethal light. A normal planet wouldn't just be damaged here, it would be stripped to atoms. And yet, something not only survived, it endured. The tension deepens when you examine the planet's orbit, incredibly tight, incredibly fast, and shockingly stable. Researchers soon realized that the planet wasn't a typical gas giant or rocky world. Its density, far higher than iron, didn't match any planetary category. Something about it was off, impossibly compact. The numbers refused to make sense. Then came the revelation that shook the astronomy community. This planet may not be made of rock or gas at all. Its density suggested a composition dominated by crystallized carbon. In other words, this world may be a diamond planet, a former star that lost its outer layers and crystallized under unimaginable pressure. An entire world of diamond, orbiting the corpse of a collapsed sun, a planet forged not through gentle planetary formation, but by cosmic violence, stripped, compressed, and transformed into one of the rarest materials in the universe. Picture it, a sphere thousands of miles wide, not glittering like jewelry, because nothing glitters in the vacuum of space, but dense, dark, and crystalline to its core. A world carved from the remnants of a star's heart, orbiting the dead ember that created it. No other place in the galaxy feels quite as eerie. A diamond forged not for beauty, but as a relic of destruction. Yet, as strange as a crystallized planet orbiting a neutron star is, the cosmos has an even harsher wonder waiting. Because somewhere else, planets orbit not around pulsars, but within the sweep of their deadly radiation beams. Worlds that endure constant blasts of high-energy particles slicing across their surfaces with clockwork precision. Planets that live in the crosshairs of a star's rotating death ray. So what kind of world survives while trapped inside a pulsar's lethal beam, enduring radiation pulses powerful enough to annihilate entire atmospheres? Astronomers were astonished when they confirmed planets orbiting PSRB 1257+12, because this wasn't just any pulsar. This was one of the first neutron stars ever discovered to host a planetary system. The mystery was immediate and unnerving. How could any world possibly survive in the shadow of a stellar corpse that radiates death every single second? A pulsar isn't warm, gentle, or life-giving. It's a spinning cinder of collapsed matter rotating hundreds of times per second, firing focused beams of radiation across the cosmos like a cosmic machine gun. Any planet nearby should have been obliterated long ago. And yet, somehow, these worlds survive. To understand the terror these planets endure, you must grasp the nature of the pulsar's deadly beams. Every rotation sweeps space with jets of high-energy radio waves, X-rays, and gamma rays. These aren't soft pulses of light. They are concentrated blasts of radiation capable of sterilizing anything they touch. When the pulsar spins, these beams slice through space with the precision of a lighthouse, but the lethality of a directed energy weapon. Anything caught in their path is bombarded relentlessly. Molecules twisting, bonds breaking, atoms ripped apart by the sheer violence of the radiation. Now imagine being a planet in that sweep. The tension builds when astronomers realized the orbits of these planets, precise, stable, yet positioned directly in the path of the pulsar's rotating beams. That means the worlds endure a constant rhythm of radiation strikes, like the ticking of a cosmic clock. Every rotation brings another blast. Every sweep delivers more energy than Earth receives in days, concentrated into milliseconds. Their surfaces must be scorched. Their atmospheres, if they ever had any, would have been stripped away long ago. These planets don't merely exist near radiation, they live inside a perpetual storm of it. The revelation came when scientists analyzed the environment more deeply and discovered that these planets had somehow survived countless eons of bombardment. They weren't destroyed, vaporized, or blasted apart. They persisted. Some even retain measurable mass and structure. They are, in many ways, the ultimate survivors. Worlds so hardened by radiation that nothing we know of could live there, but the planets themselves refuse to yield. They are monuments to endurance in a realm where endurance should be impossible. Standing on the surface, if you could, would mean standing in the path of a star's deadly heartbeat. The sky would pulse with invisible radiation flashes. The ground would be frozen in a state of permanent chemical destruction. The concept of day or night would be meaningless, because the true environment would be dictated by the pulsar's rotational rhythm, not by sunlight. It is a world built under the hammer of stellar death, shaped by bursts of energy that would annihilate Earth-like planets in an instant. But even a world living inside a star's radioactive crossfire isn't the strangest place the universe hides, because somewhere else, a planet exists with a completely different kind of hostility. Not deadly beams, not atomic destruction, but methane so hot it should be impossible. A world where methane doesn't freeze or liquefy, it boils. A world whose atmosphere holds burning ice and chemical storms that defy everything we know. So what kind of planet has clouds of superheated methane in an atmosphere that should not be able to exist at all?
Astronomers were baffled the moment they examined GJ436b,
Because the planet appeared to be covered in ice, despite temperatures that should melt, boil, and vaporize every molecule of water instantly. This was the mystery. A world so hot that its atmosphere scorches at over 800 degrees Fahrenheit, yet its surface seems locked in solid form. Ice that refuses to melt, ice that burns without burning. A contradiction so severe that even seasoned researchers questioned whether their instruments were malfunctioning. How could a planet be both blistering hot and frozen? How could water remain solid in conditions that defy every law of thermodynamics as we know them? The tension deepens as you examine the planet's environment. The atmosphere roils with heat. Methane, normally a gas at extremely low temperatures, should be present, but much of it is mysteriously depleted, chemically shattered by the planet's furnace-like conditions. Hydrogen and helium sweep across the skies in thick, turbulent layers. Radiation bakes the outer atmosphere. There is nothing here that resembles calm, cold stability. By all logic, any ice should be violently vaporizing into steam. But that's where the physics turns alien. Because this is no ordinary ice. This is Ice 7 and other exotic phases, forms that cannot exist on Earth's surface. They form only when water is subjected to crushing forces so enormous they squeeze the molecules into tightly locked lattices that resist heat. On GJ436b, gravity itself provides that crushing pressure. The planet's mass pushes downward with such intensity that even at scorching temperatures, the water remains solid. The heat tries to melt it, the pressure refuses to let it. The result is a nightmarish contradiction: burning ice, solid water hotter than boiling oil, locked in place by the planet's own weight. Imagine standing there, not that you could. The ground beneath your feet would be a searing hot solid crystal. Above you, the air would ripple with heat waves strong enough to kill a human in fractions of a second. The atmosphere's hydrogen would glow faintly from the radiant temperature. Methane would break apart and reform in chaotic chemical storms. And the ice would sit unmelted, a reminder that in the universe's harshest corners, pressure can overpower even fire. This planet challenges the most basic order of nature. We expect heat to melt ice, cold to freeze water, pressure to compress gases. But here, heat and pressure battle constantly, each trying to dominate the planet's identity. And pressure wins, leaving behind a surface that feels like a furnace disguised as a glacier, a paradox turned into a planet. But as strange as burning ice is, the cosmos has far darker worlds waiting, worlds where the atmosphere isn't boiling water or shattered methane, but something far more terrifying. Because just a few planets away in the galactic catalog lies a world whose skies aren't simply toxic, they're weaponized. A place where clouds dissolve metal, where pressure can crush submarines, and where temperatures soar high enough to destroy spacecraft in minutes. So what kind of planet possesses an atmosphere so corrosive and deadly that even robotic landers melt, dissolve, or collapse the moment they touch its surface? Astronomers have always looked at Venus with a mix of awe and unease. How could Earth's twin, nearly the same size, nearly the same mass, born from the same primordial disk, become something so violently different? From afar, the planet glows softly beneath thick golden clouds, almost serene, almost inviting. But that calm appearance hides a world that has transformed into a monstrous reflection of Earth, a planet that shows how a familiar world can warp into hell itself. The mystery of Venus isn't that it's hostile, many planets are. The mystery is why this one, so much like Earth, turned into the most brutal planet in the solar system. The tension begins the moment you peer through the atmosphere. Where Earth has blue skies, Venus has a suffocating blanket of sulfuric acid clouds, layers upon layers of corrosive vapor swirling endlessly in a death shroud. These clouds don't just hover, they actively eat away at anything that tries to pass through them. Spacecraft descending into Venus's atmosphere are sandblasted by acid droplets, their protective coatings fizzing and peeling away as the toxic rain gnaws at metal, wiring, and insulation. Above the clouds, super-rotating winds rage at hundreds of miles per hour, circling the planet in mere days, stirring the atmosphere like a cosmic cauldron. But the real horror lies on the surface below.
The air pressure is so immense, 92 times greater than Earth's, that it would crush submarines, flatten vehicles, and implode human lungs in an instant. Standing on Venus would feel like trying to breathe at the bottom of an ocean of gas. The heat radiating from the atmosphere is so intense that the ground glows faintly in infrared, like the surface of a smelting furnace. And then comes the revelation that rewrites every expectation. Despite orbiting farther from the Sun than Mercury, Venus is hotter, much hotter. Its surface reaches 900 degrees Fahrenheit, hot enough to melt lead, zinc, and many forms of steel. Hot enough that even the toughest landers humanity has ever built survived only minutes before their circuits fried, their hulls softened, and their electronics died in the inferno.
The atmosphere itself is a deadly mixture of carbon dioxide thick enough to choke light and seal in heat with runaway greenhouse intensity. The little sunlight that pierces the cloud layers becomes trapped, absorbed, re-emitted, absorbed again, turning the planet into a pressure cooker with no escape valve. The ground is a landscape of volcanic plains, crumpled mountains, and ancient lava flows, all smothered beneath skies so dense that standing outside would feel like being wrapped in boiling asphalt. And if the crushing pressure, molten temperatures, and acidic atmosphere weren't enough, Venus has one final insult: a chemistry so corrosive that metal dissolves, probes melt, and even titanium warps under prolonged exposure. This world doesn't merely kill machines, it digests them. Yet for all its horrors, Venus is just one flavor of planetary violence. Because as lethal as this world is, the next place in our cosmic descent is even more chaotic. Not because of heat or acid or pressure, but because of storms that dwarf anything ever witnessed on Earth. Storms that span entire planets. Storms that rage for centuries. Storms so vast and so powerful that they reshape the atmosphere on a scale that defies comprehension. So what kind of world is dominated by storms the size of Earth itself? Storms that never die, never weaken, and never stop. Jupiter has always fascinated and unsettled astronomers because it defies the very idea of calm. Unlike Earth, where storms rise and fade, where weather shifts and eventually dissolves, Jupiter is a world where storms never stop. The entire planet is a swirling monument to atmospheric violence. Bands of color that stretch for thousands of miles, churning, colliding, and folding into each other in a restless cycle that has raged for centuries. The mystery begins with its sheer scale. A planet so massive, so turbulent, that the weather systems we know on Earth look like stray breezes beside it. The tension deepens as you descend into Jupiter's atmosphere. At the top lie streaks of ammonia clouds, drifting like ghostly ribbons across the sky. Beneath them churn deeper layers of ammonium hydrosulfide, water vapor, and chemical storms that roll and twist through a depth that has no true bottom. Every layer adds new winds, new temperatures, new pressures. This planet's sky isn't a thin blanket, it's an abyss, a storm-filled ocean of gas that stretches tens of thousands of miles downward, each region wilder than the last. Lightning bolts flash with energies thousands of times stronger than Earth's. Turbulent vortices spin endlessly. Pressure rises until gases compress into unfamiliar forms. Jupiter doesn't have weather. Jupiter is weather. And at the center of this chaos looms the Great Red Spot, the most terrifying storm in the solar system. Larger than Earth itself, this swirling blood-red vortex has raged for over 3 centuries without weakening. Winds inside the storm rip across its perimeter at unbelievable speeds, carving circular patterns thousands of miles wide. No hurricane on Earth has come close to its scale or longevity. It is a planetary wound that refuses to heal, a storm so massive it could swallow continents whole and still have room to stretch. But the Great Red Spot is just the most famous of Jupiter's nightmares. The planet is covered in storms, white ovals, brown barges, chaotic belts, and swirling eddies that erupt suddenly and can grow larger than Earth within weeks. The winds in these storms exceed 380 miles per hour, far beyond anything Earth's atmosphere has ever produced. Some regions push even faster, hinting at deep layers where wind shears shred gas into turbulent ribbons. Jupiter's storms compete, merge, devour each other, and reform. an endless dance of atmospheric aggression that repeats across thousands of miles. And Jupiter isn't dangerous only on its surface. Its magnetic field is a monstrous invisible engine capable of accelerating particles to energies that would kill a human instantly. Its radiation belts are so intense that spacecraft must perform careful maneuvers just to survive long enough to gather data. This is a world that resists exploration, a world that punishes proximity, a world where nature refuses to calm down. Yet even Jupiter's wrath is only part of the story, because orbiting this giant is a moon unlike any other, one that doesn't just endure Jupiter's magnetic fury, but responds with violent eruptions of its own. A moon that spews plasma into space, feeding Jupiter's magnetosphere with charged particles in a storm of volcanic electricity. A world so volcanically active that its surface is constantly blown apart and rebuilt. So what kind of moon erupts with such ferocity that its volcanic plumes reach hundreds of miles high, electrifying an entire region of space? Io announces itself not with quiet landscapes or gentle geologic shifts, but with violence. Raw, unrestrained, continuous violence. From the moment astronomers captured the first images of Io, it was clear this wasn't just another moon orbiting a giant planet. This was the most volcanic world ever discovered, a place where the ground doesn't wait centuries to erupt, it erupts constantly. Every inch of its surface is under siege from its own interior, a world cracking open again and again as molten rock bursts outward in fountains taller than skyscrapers. Lakes of lava spread across plains, and eruptions fling sulfur high enough to escape the moon's gravity entirely. Io is not peaceful. Io is not stable. Io is a celestial explosion wearing the mask of a moon. The tension intensifies when you examine what Io's volcanoes actually produce. These aren't the dark, basaltic plumes familiar from Earth's eruptions. On Io, the volcanic jets blast out sulfur and sulfur dioxide, launching enormous plumes that can rise 300 miles into space, higher than the orbits of some satellites around Earth. These plumes bloom into massive umbrellas of gas that spread out across the sky, illuminated by Jupiter's reflected light in yellow, orange, and red. Some plumes are so huge that they cast enormous shadows on the terrain below, painting the moon's surface in eerie patterns. And every eruption adds new layers of material, dropping sulfur snow that colors the landscape in hues ranging from blood red to neon yellow. The surface beneath these plumes is a battlefield of constant change. Lava lakes pulse like beating hearts. Crusts solidify, only to shatter moments later as new eruptions force their way through. Mountains collapse under seismic stress. Entire regions melt and reform within days. Io's terrain never stops moving. Its surface is rewriting itself constantly, torn apart by the intense tidal forces from Jupiter's gravity. The giant planet pulls on Io so violently that the moon stretches and compresses with every orbit, creating frictional heat inside that fuels its relentless volcanic activity. This internal torture makes Io a world in a perpetual state of geological fury, its landscapes younger than most human civilizations because they barely last long enough to become old. If you stood on Io, impossible of course, the ground would tremble beneath your feet. The airless sky would glow with the light of lava fountains erupting in the distance. You might watch a mountain crack open and collapse. You might witness a sulfur plume erupting with the force of an atomic blast, its gases arching into space before freezing and falling back as bright yellow crystals. Nothing here is quiet. Nothing is still. Io is the universe's blueprint for controlled chaos. But the cosmos doesn't stop with molten fury. If Io is a moon shaped by fire, the next world is shaped by ice. Ice under tension, ice under stress, ice split into titanic fractures so deep that they hint at oceans hidden far below the surface. A world carved not by lava but by cracking frozen crust, shifting plates, and the groaning stretch of tidal forces. So, what kind of planet or moon lies beneath a shell of frozen water split by massive fractures, hiding an ocean in the darkness below? Europa has always whispered a quiet, eerie mystery. Unlike Io's explosive fury, this moon hides its violence beneath a deceivingly calm white exterior. From afar, Europa looks peaceful, a smooth, gleaming sphere wrapped in ice. But get closer and the truth reveals itself.
The entire surface is scarred with cracking, groaning fractures, deep gouges that stretch for thousands of miles. These lines aren't random. They form a chaotic spiderweb of stress marks, discolorations, and shifting plates that tell a disturbing story. Europa is not still. Europa is not solid. It is a shell, thin, fragile, and alive with movement.
The tension builds as scientists probe what lies beneath that icy crust. They found elevated salinity signals, strange thermal patterns, and magnetic interactions that all point to something astonishing: a global ocean, stretching for miles beneath the frozen exterior. Not a shallow sea, but a vast, pitch-black ocean deeper than Earth's Mariana Trench, possibly containing more water than all of Earth's oceans combined. But this ocean isn't friendly. The surface above it is lethally cold, hundreds of degrees below freezing. The vacuum of space hovers just inches above the crust. The ice is so bitterly frigid that even metal becomes brittle. Nothing warm or soft survives here. Yet beneath that kill zone of frost lies a realm of unimaginable depth and pressure. And those two layers, the deathly cold ice above and the crushing ocean below, exist in a perpetual struggle. Jupiter's immense gravity pulls and releases Europa in a constant rhythm, flexing the moon like a rubber ball. This rhythmic distortion creates tidal forces powerful enough to generate heat deep inside the moon, possibly warming the ocean and sending currents upward. But those same forces also tear the crust apart, fracturing the ice, widening old cracks, creating new ones, and causing entire plates to drift and collide. Some cracks appear to vent water vapor into space, geysers erupting through miles of ice, freezing instantly as they break into the vacuum. Standing on Europa, if one could without dying instantly, would feel like standing on a world-sized ice rift. You would hear nothing in the airless environment, but the ground beneath your boots might shift imperceptibly as the crust flexes. Beneath you, an ocean churns in absolute darkness, pressed under miles of ice that groan and split under gravitational stress. Europa's surface is a map of these struggles. Stained streaks from salty brines, fractured ridges twisted by motion, patches that look as though the ice melted and refroze into smooth plates. As haunting as Europa is, its mysteries are only the beginning, because somewhere far beyond, orbiting another star entirely, lies a world whose storms don't just swirl, they glow. A planet where atmospheric tempests shimmer with metallic vapors and pulse with eerie neon green light. A world where the weather itself radiates a color no human has ever seen in a natural sky. So what kind of planet brews storms so intense and exotic that they shine like shimmering green aurora sweeping across a gas giant atmosphere? Astronomers were mesmerized the first time they studied HATP 7b because its atmosphere displayed something no other known world had shown before: storms that shimmer. Not with lightning, not with fire, but with an eerie glow. Clouds that seem to shift color, brighten, and dim as if made from reflective metals drifting through the sky. This wasn't the soft, muted reflection of water droplets or ice crystals. This was something stranger, something alien. A world where the storms themselves appeared to glint like polished metal catching starlight, giving the entire atmosphere a surreal, shimmering quality. The mystery deepened when astronomers tracked the clouds over time. Instead of behaving like stable weather systems, these clouds shifted rapidly across the planet's surface, appearing and disappearing with astonishing speed. One moment the sky might be blank, scorched clean by intense heat. The next, massive banks of clouds would form out of nowhere, glittering like metallic smoke. These formations move so unpredictably that researchers struggle to map them. The entire atmosphere seemed to be in a state of continuous transformation, roiling, shimmering, collapsing, reforming, faster than any model predicted. This wasn't a cloud layer. This was atmospheric chaos, sculpted by brutal temperature differences between the day and night side of the planet. HATP-7b is tidally locked, meaning one side faces its star eternally, roasting under relentless light, while the opposite side sits in permanent darkness. The day side reaches temperatures so blistering that chemistry itself breaks apart. Molecules can't maintain their bonds. Clouds evaporate before they fully form. On the night side, though, temperatures plummet far enough that exotic vapors can condense. Vapors made not of water, but of metals. Researchers found signs of corundum and other minerals that can crystallize into metallic clouds. These clouds, carried by raging winds, drift toward the day side where they heat, glow faintly, then vaporize again, creating luminous storms that shimmer like molten gemstones. This revelation that the planet's glowing storms come from metallic vapors being torn apart and remade turns HATP-7b into one of the strangest atmospheres in the universe. Clouds made from materials that form sapphires and rubies on Earth drift across this world in shimmering waves. Storms reflect starlight like sheets of metal. Temperatures rise and fall so rapidly that crystals may form and vaporize within minutes. The entire sky becomes a churning mosaic of light and mineral dust, glowing like auroras made from gemstones. Imagine looking up from this planet. If you could survive its furnace-like heat, the sky would flicker with shimmering patches, reflections dancing in the high atmosphere as metallic clouds swirl across the horizon. Storm fronts would appear like luminous green or blue flashes, then dissolve into nothing. The planet would feel alive, constantly reshaping itself in waves of metallic vapor and glowing turbulence. But even storms made of crystal and metal aren't the universe's darkest trick. Because while HATP-7b dazzles with shimmering clouds, the next world hides in pure darkness. Not because its storms are dim, but because it has no star at all. A planet that drifts through space alone, exiled from any solar system, isolated in eternal night. No sunrise, no warmth, no host star to anchor its orbit. So what kind of world wanders starless through the void, frozen, silent, and lost between galaxies? Rogue planets drift through the galaxy like abandoned ghosts, worlds cast loose from their stars, sentenced to wander in eternal darkness. Unlike normal planets, they have no sunrise, no orbit, no gravitational anchor. They drift through the Milky Way completely alone, illuminated only by the faint glow of distant stars or the soft red ember of internal heat left over from their formation. The mystery surrounding these worlds is simple and chilling. What happens to a planet when it loses its sun? What becomes of a world plunged into endless night with no warmth, no light, and no energy source to sustain it? The tension builds as astronomers imagine the conditions these starless wanderers endure. With no star to warm them, temperatures plummet to levels colder than anything in the solar system. Their atmospheres collapse, freezing onto the surface as sheets of nitrogen, oxygen, or methane ice. Winds disappear, weather systems die. Oceans solidify into stone-like slabs. The planet falls silent. No day-night cycle, no seasons, no light. Only emptiness. The darkness is total, broken only by the faint shimmering of starlight so far away that it barely reaches the surface. A rogue planet is a world in cosmic exile, drifting through a void so vast that centuries can pass without encountering another star. Their journeys are equally haunting. With no orbit to guide them, rogue planets follow straight-line paths through interstellar space, paths that take them far beyond familiar constellations, through clouds of dust and regions of emptiness, thousands of light-years wide. A single rogue planet may drift silently for eons, its temperatures dropping so low that even the hardiest materials become brittle. Yet some may still carry internal heat from radioactive decay or primordial warmth, creating underground oceans or geothermal vents in a place otherwise dominated by perfect, suffocating darkness. These worlds could host secret environments completely sealed off from the universe above. And then comes the revelation that unsettles astronomers most. These planets are not rare. They're not even uncommon. Research suggests that the Milky Way may contain billions, possibly even trillions of rogue planets drifting undetected between the stars. Our telescopes barely catch them. They give off no light. They produce no shadows. Most are invisible, detectable only when they briefly distort the light of distant stars through gravitational microlensing. At any moment, countless such planets could be passing near our solar system without ever being noticed. A hidden population of dark worlds roaming the galaxy, silent, frozen, and infinite in number. These are the loneliest planets in existence, worlds abandoned by gravity, stripped of their suns and thrown into a universe where the only constant is darkness. And yet even these wandering giants are not the most extreme objects the cosmos holds, because out there exist planets so massive, so dense, and so overwhelming in scale that they push the limits of what physics believes possible. Gas giants dozens of times more massive than Jupiter. Worlds whose gravity can crush atmospheres, collapse clouds into metallic rain, fold space around them, and flirt with the threshold between planet and star. So what kind of world grows so heavy, so colossal that it nearly becomes a star but remains trapped forever as a supergiant planet straining against the limits of physics? Astronomers coined the term super Jupiters for a reason, because these worlds aren't merely big, they are absurd. Gas giants so massive that Jupiter, the ruler of our own system, looks puny beside them. Some weigh 10 times more than Jupiter. Others reach 20, 30, even 40 times Jupiter's mass. These are planets swelled with so much material that the boundaries between planet and star begin to blur. And the mystery that first stunned researchers was simple. How does a world this massive even exist without igniting into nuclear fire? The tension begins the moment you imagine standing anywhere near one of these gravity giants, if standing were possible at all. Their gravity is crushing, not figuratively, literally. On the boundary layers of their atmosphere, pressure skyrockets to levels that shred molecules and compress gases into exotic states. Hydrogen, normally a light, airy gas, is forced into metallic hydrogen, a substance so strange and conductive it behaves more like molten metal than gas. Lightning on these worlds might be driven by metallic storms crackling through compressed layers. Winds could carve tunnels through gas dense enough to behave like liquid. Entire atmospheric structures collapse under weight so immense that the line between sky and interior becomes a blurred, churning, super-pressurized abyss. Deeper down, the crushing forces multiply. Gravity drags the atmosphere inward so violently that the concept of a surface disappears. It becomes an ocean of hydrogen, then a sea of metallic hydrogen, then deeper still into layers where atoms are squeezed closer than physics prefers. On some of these giants, the pressure is so extreme that the core may be a superheated sphere of exotic matter, glowing not with fusion, but with the sheer heat of gravitational compression. These planets aren't gently lit. They radiate warmth from their own internal compression, eternally trapped between two identities. In the darkness of the galaxy, they drift like embryonic stars frozen in cosmic limbo. These worlds are some of the most extreme environments imaginable. Gravity giants so powerful that even light bends subtly as it passes near them. If Jupiter's gravity is a giant's handshake, then these planets are a cosmic vice grip, squeezing their atmospheres into states of matter we barely understand. They challenge the definitions of what a planet can be, pushing planetary science to its breaking point. But as overwhelming as these giants are, the universe still has stranger, more violent phenomena waiting in its exoplanet catalog. Because out there exists a world where oceans don't behave like Earth's gentle tides. Instead, they surge, collide, and rise into 3-mile-high waves, mountains of molten metal or superheated fluid heaving across a blazing surface. A world where oceans aren't made of water at all, but of liquids that ripple with reflective fire. So what kind of planet hosts oceans of metal, tides of molten brilliance rising miles into the sky and crashing back down with planetary force? Astronomers were stunned when they discovered worlds where the oceans, shimmering beneath alien skies, were not made of water at all, but metals. These planets orbit so close to their stars, bathed in such overwhelming heat that ordinary minerals and elements melt into glowing liquid surfaces. Instead of blue waves and white foam, these worlds host mercury-like seas, vast, reflective surfaces that boil, churn, and heave in temperatures hot enough to vaporize rock. The mystery that first shocked researchers wasn't that metal existed on these planets. Metal is everywhere. But that entire oceans of it could form, spreading across the surface like molten mirrors.
The tension starts with the heat. On these worlds, the day side is blasted by radiation so intense that surface temperatures can soar above 3,000 degrees Fahrenheit. That's hot enough to liquefy metals like lead, zinc, tin, and even vaporize silicates. The ground itself sweats molten metal. Rocks soften, minerals melt into glowing pools, and what would be mountains on Earth might slump into valleys of liquid metal under the crushing grip of extreme heat. In such an environment, the concept of solid ground becomes fragile, transient, melting by day, partially refreezing by night, constantly cycling between forms like a planet-sized forge. The oceans that form under such conditions are unlike anything humans have ever seen. They glimmer like polished chrome under the glare of a nearby star, reflecting brutal light outward in dazzling flashes. Waves ripple through these metallic expanses, but they don't crash gently like Earth's seas. They surge with the alien physics of superheated fluids, pushed by winds that howl at thousands of miles per hour. Some models suggest tides rising miles high, slow-moving tidal giants that swell and recede like molten mountains sliding across the horizon. Imagine standing on the edge of such a sea, if survival were possible, and watching a wall of liquid metal climb the sky before collapsing with a thunderous, world-shaking crash. And these oceans aren't uniform. In some regions, different metals separate like layers in a bizarre chemical cocktail. Lighter molten metals float atop heavier ones. Vaporized minerals condense above the surface, creating clouds that shimmer with metallic droplets before raining back into the glowing seas. The air itself may contain metal vapor, drifting and refracting light like an atmosphere made of glitter and fire. This is not weather. This is metallurgy on a planetary scale, an entire world behaving like an open-air foundry. But the most astonishing revelation is that these seas aren't rare mistakes. They're stable in the right environment. If a planet orbits close enough to its star, if the right minerals dominate its crust, and if the temperature remains extreme but not completely vaporizing, oceans of molten metal can form, evaporate, condense, and flow for billions of years. They become an equilibrium, a burning, shimmering cycle of metallic tides that never cool. Yet even these shimmering hellscapes aren't the universe's final escalation. Because while molten oceans are terrifying, the next world is ruled not by heat and metal, but by gravity. A planet so close to its star that its interior screams under the strain. A world so violently stretched and compressed that its entire crust fractures, melts, and convulses in tidal agony. A world locked in a constant gravitational scream, twisted by forces that nearly tear it apart every orbit. So what kind of planet exists in the state of permanent torment, stretched and crushed until its very core cries out under the unbearable pull of its star? Some worlds don't simply orbit their stars, they suffer because of them. Astronomers studying tidally tortured planets quickly realized these weren't ordinary exoplanets, but victims locked in gravitational prisons. Unlike stable orbits where gravity gently guides a planet along, these worlds are caught so close to their stars or in such extreme orbital eccentricities that the star's pull doesn't just influence them, it reshapes them. These are planets stretched and twisted, their crusts cracking, their mantles contorting, their very interiors groaning under the relentless tug of war between gravity and orbital motion. The mystery begins with those distortions, not minor flexing, but full-body deformation on a planetary scale. The tension builds once you understand how tidal forces operate at this magnitude. On Earth, tides gently lift and lower oceans. On moons like Io, tides fuel volcanoes. But on tidally tortured worlds, these forces escalate into catastrophic extremes. The star's gravity tugs the planet one way during part of its orbit and another way during the next, ripping at the interior with colossal stress cycles. The crust stretches until it fractures. The mantle heats until it softens and swells. The entire globe behaves like a cosmic stress ball squeezed by a giant hand, compressed and elongated over and over again in a brutal cycle with no rest, no relief, no escape. Inside these planets, the consequences are devastating.
The friction generated by constant flexing creates intense internal heating, enough to liquefy layers that would otherwise remain solid. That heating triggers massive quakes that can ripple across entire hemispheres. Volcanoes erupt in chains, not isolated peaks. Fault lines spread like spider webs through every region of the crust. Some of these worlds experience global resurfacing events, where molten rock floods across vast territories, wiping out old terrain and creating new landscapes in geological instants. The surface becomes a battlefield of tortured geology. Lakes of magma expand and retract as tides squeeze the interior. Entire mountain ranges rise and fall like breathing organs. Pressure waves travel through the crust with so much force they fracture continents before they even form. The atmosphere, if any remains, becomes a haze of volcanic gases, sulfur, carbon dioxide, metal vapors, venting continuously as the planet attempts to relieve stress but fails, every cycle worsening instead of easing. Some of these worlds may even glow faintly from space, heated not by their star's light, but by their own internal agony. Others release plumes of molten minerals into space, spraying vaporized rock into their orbital paths. The more dramatically stretched they become, the more violent their interiors grow until stability becomes a distant dream. These planets are not worlds, they're pressure cookers, their cores screaming silently under gravitational torture. But even these tortured planets, racked by gravity's relentless grip, pale in comparison to what may lurk on the edges of our own solar system. Because while these worlds are destroyed by their stars, another kind of world represents a different threat entirely, one that doesn't just suffer, it endangers. Astronomers have long debated the existence of a mysterious, massive planet lurking far beyond Neptune. One so large its gravity could destabilize comets, disrupt orbits, and alter the architecture of our solar system itself. A world that, if it ever drifted inward, could wreak havoc on Earth in ways we can barely imagine. So what kind of hypothetical world lies hidden in the darkness, so massive, so distant, and so disruptive that its mere existence could end humanity if it wandered too close? For decades, astronomers have whispered about a strange and unsettling presence lurking far beyond Neptune, a world so distant, so faint, and so well hidden in the outer darkness that no telescope has yet seen it directly. They call it Planet X, or Planet 9, a hypothetical giant drifting at the edge of the solar system, its existence inferred not by light, but by the disturbance it leaves in its wake. The mystery springs from a simple, eerie observation. Something massive appears to be tugging on distant objects in the Kuiper Belt, stretching orbits, twisting paths, clustering icy worlds into strange patterns that shouldn't exist naturally. Something enormous, invisible, and far from the warmth of the sun. The tension grows when you examine these gravitational clues in detail. Astronomers notice that a handful of extreme trans-Neptunian objects, small icy bodies billions of miles away, share unusual orbital features. Their paths tilt the same way. Their perihelia cluster together. Their orbits stretch out like cosmic spears, pointing in nearly the same direction. Statistically, this alignment shouldn't happen. It's too neat, too organized, too unnatural. The only explanation that fits the data is the presence of a massive object shepherding these worlds from afar. An unseen giant whose gravity shapes a region of space so distant that sunlight is barely more than a memory. And that leads to the revelation that ignited one of the greatest astronomical hunts in modern history. Planet X might be a super-Earth, a world 5 to 10 times the mass of our planet. Not a gas giant like Jupiter, not a frozen dwarf like Pluto, but a colossal rocky or icy world, bigger than Earth, heavier than Mars, darker than anything in the solar system except black space itself. It could be orbiting so far away that 1 year on this world lasts 10,000 to 20,000 Earth years. Its skies will be black as ink. Its atmosphere, if it has one, would be a frozen shell. Any moons it possesses would circle it with glacial slowness. Planet X could be the most isolated planet the sun has ever claimed. But the danger lies not in its cold or its darkness, it's in its influence. A super-Earth drifting at the edge of our system could gravitationally disturb comets in the Oort cloud, sending icy missiles toward the inner planets over long timescales. If its orbit ever changed, even slightly, it could destabilize the delicate clockwork of our solar system itself. Worst-case models imagine tidal interactions that could shift asteroid belts, warp orbital residences, or even nudge planets subtly over millions of years. Nothing immediate, nothing sudden. But over astronomical time, Planet X could function as a silent architect or destroyer of our system's stability. The idea that a massive, disruptive, unseen world might be drifting just beyond our reach is both thrilling and horrifying. Astronomers continue to scan the sky, sweeping the darkness for hints of its silhouette. If Planet X exists, it may be the last major world waiting to be discovered in our own solar system, a final monster hiding in the cold. Yet, even this theoretical super-Earth is not the end of our cosmic descent, because beyond all known worlds, beyond all star-scorched giants and frozen rogues, and diamond cores and molten seas, lies a final category so extreme that it barely fits within the bounds of imagination. Not planets shaped by fire, ice, gravity, or storms, but hell planets, worlds so destructive, so hostile, so violently impossible that they make every nightmare world before them seem tame. So what then is the ultimate form of cosmic terror? What does a world look like when nature unleashes every force, heat, poison, pressure, radiation into a single monstrous creation? Astronomers use the term hell planets reluctantly because it implies a level of hostility that stretches beyond known physics into the realm of nightmares. But some worlds are so extreme, so savage in their environmental brutality that no other word fits. These aren't the scorching giants we've already visited, nor the frozen tomb worlds drifting through starless voids. These are theoretical planets, cosmic horrors predicted by models, hinted at by strange observations, or imagined by researchers exploring the edge of what the universe might allow. The mystery surrounding these worlds isn't merely that they're dangerous, it's that they may be so hostile, so violently unstable that they shouldn't exist at all, and yet they might. The tension builds as we explore what such worlds could be. Some may be forged in pure fire, planets orbiting so close to their stars that their surfaces glow white hot, hotter even than Kelt 9b. Worlds where entire mountains vaporize into metallic fog and rain falls as molten alloys that flash boil upon impact. Others may possess atmospheres that behave like weapons, layers of sulfuric acid so thick they dissolve spacecraft mid-descent, clouds of chlorine or fluorine gas ready to ignite with the slightest chemical spark, or toxic vapors that detonate under pressure. Some theorize hell planets may carry atmospheres so dense that a single step would crush bones. Air so heavy it behaves like liquid metal, pushing down with relentless force until nothing organic could survive. But heat and poison are only part of the terror. Some hell planets could be ruled by gravity itself. Super-Earths pushed to extremes, their surfaces so crushing that even the strongest materials on Earth would collapse instantly. On such worlds, mountains would flatten, oceans would be squeezed into bizarre, high-pressure forms, and human bodies would fail in less than a heartbeat. Picture a planet where the atmosphere sits at 1,000 times the density of Earth's, where every movement feels like pushing through molten lead, where even light struggles to escape the gravitational pull. And then there are the worlds shaped by violent radiation, orbiting dead stars or pulsars that flood their surfaces with constant blasts of gamma rays. Planets where atmospheres are torn apart faster than they can form, where ground-level radiation would sterilize anything within seconds. Some of these hypothetical planets might even glow eerily under the assault, like dying embers trapped in a storm of cosmic fire. The most unsettling revelation is that these worlds, these dizzying extremes of nature, may not be rare. They may not be hypothetical at all. They could exist unseen, lurking in the vast darkness between stars, orbiting dim suns we haven't yet detected, hiding behind dust clouds, or drifting rogue through the galaxy. Our telescopes have only glimpsed a fraction of the planets that might be out there. For every world we know, there may be hundreds waiting, undetected, wrapped in storms, cloaked in toxic haze, or burning in perpetual daylight. Hell planets could be common. They could be everywhere. And if so, they're a reminder of something humbling.
The universe does not care about comfort. It does not favor life. It builds worlds out of violence, pressure, radiation, and fire. It forms landscapes that would incinerate, crush, poison, or freeze anything that tries to touch them. The planets we've explored in this journey are only the ones we know, the ones we've managed to glimpse with our tiny instruments from across the abyss. But beyond those, in the places our telescopes have yet to see, in the unseen corners of the galaxy, what horrors still lurk unfound, waiting in the cosmic dark for the moment our technology becomes strong enough and bold enough to discover them. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. If you enjoyed the video, consider subscribing to the channel and like the video.